Okay, so Mpumalanga, pre-trial 2024 paper 1, right? This is the pre-trial paper, and this is the paper 1. All right, so yeah, it says for 1.1, we just normal question 1 solving for x correct to 2 decimal places when necessary. So the first one is the easiest one. We know that it's factorized and equal to 0, which means that we're basically going to have x equal to minus 3 or x equal to 2, essentially. All right, then the next one, we're going to have this as 2x squared plus 3x minus 7. This is going to, it's actually, they should have said rounded off to 2 decimal places. So you're just going to use the quadratic equation here. Luckily in this one, everything's in the right order. It's ax squared plus bx plus c. So we know our a value is 2, our b value is 3, our c value is minus 7. And if you put that into the quadratic, you're going to end up with x equal to 1.27 or x equal to minus 2.77. Okay, that's easy. And don't forget, you've got to show your quadratic formula step in 1.1.2. I'm not doing it, but you have to show it. You get a mark for it. It's worth 4 marks. You get a mark for the quadratic equation. Now, 1.1.3, they give us 2 to the power of x minus 8. Oh, that's already looking like a good question. Let's go and see what we can do with that. We can use all of the space at the top here, actually. Right, so 1.1.3, we have this as 2 to the power of x minus the 8 minus the 2 times 2 to the power of x over 2. Now, I've told you this before. Oh, sorry, is equal to 2 to the power of, 2 times 2 to the power of x over 2. Now, I've told you this before. If your exponents, if your variable exponents are double or half one another, that means that you're going to use k method, right? That means that you're basically going to use k method. So here we're going to say let the smaller one equal to k. So let 2 to the power of x over 2 equal to k. So that means here, I just want to show you that this will be k squared. Let me just show you how that will become k squared. This is 2 to the power of x over 2. If I square this side, I must square that side, and this will actually just be 2 to the power of x is equal to k squared. So now we know that 2x is k squared minus 8 is equal to 2k. Bring that over, k squared minus 2k minus 8 is equal to 0. Factorizing this is really easy. We're going to end up with 2 possible values. It's going to be, it's basically 4 and 2. So we can end up with minus 2, or k can be equal to a positive 4. Yep, 2 to the power of x over 2 equal to minus 2. This is no solution. Why is this no solution? Because a positive base to any exponent can never be equal to a negative number. A positive base to any exponent can never be equal to a negative number. Now on the other side here we have it as x over 2 is equal to 2 squared. That means x over 2 is equal to 2 because the bases are cancelled out. And therefore x is equal to 4. And that's it. Answer is x is equal to 4. Very decent question there for solving for x. Next up we have an inequality. This one's not a crazy good inequality, it's just decent. Let's do it on the side here. 7, 18 minus 9. Okay, so 1.1.4, we'll do it on this side. We have this as 7x squared plus it is 18x minus 9 plus 18x minus 9 is greater than 0. Alright, so this is what we end up with here. Alright, so now all we've got to go and do is we need to go and solve for what this is. Remember, everything's already on the left hand side. We now just got to go and find our critical values. So just use your calculator to go and sort out your critical values, right? Obviously, if you have your silver calculator, you can do it in your equations mode. So 7 for A, your B is 18, your C is 9 or minus 9. And this is minus 3, or x equal to 3 over 7. So which one's going to appear first? We know that minus 3 would appear first, and then 3 over 7 would appear second. This is positive, negative, positive. We are looking for where is our inequality positive and where is our inequality positive when x is less than minus 3 or when x is greater than 3 over 7. And that's that. Easy stuff. Easy, easy, easy stuff. I'm confident that you guys know what's going on here. All right, now on to 1.2. So 1.2, solve for x and y, just a simple simultaneous equation, this one. Actually, this simultaneous equation is dirt simple. Let me just show you here. I can actually just use this space on this side just to go and sort this out here. So basically, we're going to take this x onto that side and take this 4 onto the other side. So it's going to look like this. 4y minus 4 is equal to x. This is like our equation 1 is what we'll call it. And then we can say that xy is equal to 8. So wherever we see x, we need to put it as 4y minus 4. Wherever we see x, we need to put it as 4y minus 4. So this is your equation 2. So to sort this out, we're going to have this as 4y minus 4 into y is equal to 8. That's 4y squared minus 4y minus 8 is equal to 0. We're going to get two values for y here. We're going to get y equal, we'll divide throughout by 2, so that's just going to be y squared minus 2y minus, well, divide throughout by 4, so that's y squared minus y minus 2, so y is going to be 2, or y is going to be minus 1. Okay, then we just sub it in, take this x value, take this y value, sub it in there to get the corresponding x value. So 2 times 4 is 8, minus 4 is 4. And then for this one, 4y, which is 4 times minus 1, is minus 4 is minus 8. So those are our coordinates there. Or not coordinates, I should say x and y corresponding values. Alright, then it says write down both lines of symmetry for the graph xy is equal to 8. Now here, they just want to test your knowledge on whether you recognize that this is actually a hyperbola. So let me show you how you're going to find the axis of symmetry for this particular graph, xy is equal to 8. So this is 1.2.2. So 1.2.2, xy is equal to 8, which means that y is equal to 8 over x. This is a hyperbola. And you know that your axis of symmetry for a hyperbola is plus minus x plus p plus q, or x minus p plus q is normally the correct way of saying it. But it's basically this denominator goes there, and then this plus q, whatever it is, supposed to go there. In this case, it's just y is equal to plus or minus x, because we don't have a p value, nor do we have a q value. And that's it. Y is equal to plus minus x. Fantastic. Right, 1.3. The solutions of a quadratic equation are given by x is equal to, okay, so immediately, haha, this is more of like grade 10 and 11 more than grade 12 work. So, yeah, for us to have non-real roots, we know that what's in our root must be a negative. For us to have non-real roots, what's in our root must be a negative. So what value must k be for what's inside the root to be a negative? It must mean that 36 minus 4k needs to be less than 0. So minus 4k needs to be less than minus 36. Divide throughout by a negative. And here, dividing throughout by a negative 4 means that the sign here is going to have to change. So that means this is going to be greater than, k needs to be greater than 9. Alright, 1.3.2. What does it mean for your fraction to be undefined? It means the denominator needs to be equal to 0. So 2k just needs to equal to 0. K is equal to 0 and done. Okay, question 2. It says the first term of a quadratic sequence Tn is equal to n squared plus an plus b, which is basically just telling us we know traditionally it's an squared plus bn plus c. So you can think of like your a value being the same as your b and the b value being the same as the c value in your traditional formula. So it says is 9 and the term of the, sorry, is, I read that wrong. It says the first term of the quadratic sequence given by that is 9. So the a, let me not say a because that's traditionally not the right way. Your first term is 9, and then the term of the first difference is 11. Right? The term of the first difference is 11. Now, it says determine a and b, hence the general term. So what we need to understand from this information that they've given us is the following. So let's use this space here again at the top here. So we know that we have 9 and then we have a certain value or a certain term, and then it's the same thing. It's going to be term 2 minus term 1. And then the first difference row has a first difference of 11 essentially. So what we know so far, guys, is that, remember, we know that if we had this here and it would have been equal to something here, we know that this a value here is 1, right? The value in front of n squared is 1. Now the only way it could have been 1 is if it was 2a equal to 2, right? That's the only way that you could have got the a value there to be 1. And remember, the a value that I'm talking about is in our traditional formula, right? That's the a value I'm talking about. So we know that it's supposed to be 2a equal to 2 because we know that a is essentially equal to 1. So 2a is equal to 2. A is going to be equal to 1. Then our second formula is 3a plus b is equal to 11. So 3 into 1 plus b is equal to 11, which means b's value is just going to be 8. Fine. Then you know that it's a plus b plus c to equal to that first term. So a is 1, b is 8, plus c is equal to 9. That means c is actually equal to 0. So your traditional formula will read as follows. Tn is equal to n squared plus bn, which is 8n, plus 0. So just nothing there essentially. So that's our formula. So in the stuff that they've given us here, it's n squared plus 8n, and obviously that b value that they gave us there is 0. Alright, so we know that there. So we said a in the form that they gave us, right? A in the form that they gave us, we know that that was 8, and b is essentially 0. 2.1.2, what is the value of, what is the value of the first term of the sequence that is greater than 240? This is one of those cool questions again. It's a question I think we know by now, because we've done plenty of things like this, and you would have definitely done so many of these before. So we're going to take this equation and just set it to be greater than 240. That's it. So for 2.1.2, we're going to set n squared plus 8n to simply be greater than 240. It is now an inequality when you take this to, well, when starting it's going to be an inequality. You're now going to find your critical values because everything's on one side or on the left hand side, and your n squared or x squared is a positive. So now we can find those critical, not x, it is n. Now we can go and find those critical values. So how do we go and find those critical values? Just a normal quadratic. So we're going to go and put those values in. What is it going to be? Oh, I was trying to do that in my mind. I'm pretty sure you can. 240. 20 and 12 makes the most sense. I think it's going to be 20 and 12. Minus 240. Yep. Minus 20 and then positive 12. So on your number line, minus 20 would appear first. 12 would appear there. But again, you don't really, okay, so these are positives, these are negatives, these are positives. So you were looking for positives, as you know, right? You're looking for positives. But you can't really get a term number as a negative, so we don't use it. We're going to have to say it needs to be greater than 12. So n needs to be greater than 12. But the wording here is important, right? The wording here is super important. They're saying, what is the value of the first term of the sequence that is greater than 240, right? Greater than 240. So greater than 240 would mean that n needs to be greater than 12. So therefore, that n value is actually going to be 13. The first term is actually going to be 13. Okay. For 2.2, it says, given the arithmetic sequence 3 minus 1 minus 5. Okay, this is an easy one. Calculate the number of terms in the sequence. Dirt simple for us, right? This is very, very easy. We're going to just say Tn is equal to your first term, which is 3, plus your difference of minus 4 into n minus 1. You know that the last term is minus 89. This is 3 minus the 4 into the n minus 1. You take the 3 over, essentially. It becomes minus 3. So it's minus 89 minus 3. Divide by the negative 4. It becomes 23 is equal to n minus 1. And therefore n becomes 24. Okay, therefore n becomes 24. N is 24 terms. So this is basically the 24th term. Okay, 2.2.2. Calculate the sum of all negative terms in the sequence. Now, how many negative terms do you have here? And they want to find out the sum of it. So, you have basically a total of not 24 negative terms. You have a total of 23 negative terms. Right? You have a total of 23 negative terms. But you want to find the sum of all those negative terms, which means we know that the sum formula is n over 2 into a plus l. But this is important now to understand. Are we using the 3 or the minus 1 as our first term? We have to use the minus 1 because it's dealing with all the negative terms in that sequence. So we've got to say minus 1 plus the minus 89. And our number of terms, as we should know, is not 24, but 23. And we put that in the calculator. And that's going to be 23 over 2 into minus 90, basically. Minus 10. Okay, so minus 1. Minus 1035, minus 1035. Now, you can go and use the other formula as well, just to kind of make sure that it is correct. But yeah, that's basically what I would use. Okay, 2.2.3, consider the sequence. Okay, so that's the same sequence, but now all the way to minus 389. Determine the number of terms in this sequence that will be exactly divisible by 3. All right, so we want to find out how many terms in this here is exactly divisible by 3. So what we normally do is we've got to go and find out, is our last term actually divisible by 3? So minus 389 divided by 3. Unfortunately, that's not going to be divisible by 3. So we're going to have to do the following. So we're going to set this up like this here. We know 3 minus 1 minus 5 and so onwards. All right. All the way to, well, actually, let's write this here as minus 9 because we know that's the next one. That's going to be divisible. And then all the way to minus 389. But then if we're going this way, right, if we're going to find that other one, we're going to have to basically like add 4 to it. So it's minus 389 plus the 4 essentially, which is minus 385. Is this divisible by 3? Let's find out. Nope. Now we're going to add 4 again. Minus 385 plus the 4. Minus 381. So minus 381 divided by 3. Yes. So this is the last term that is divisible by 3. Right? That's the last term that's divisible by 3. This is the first term that's divisible by 3. Which means we've got a new sequence here. It's 3 minus 9 all the way to minus 381. So now we need to find out how many terms are there from here to there. Easy. So Tn is equal to A plus D into n minus 1. Your Tn is minus 381. Your A value is 3. Your difference is how much? What are you subtracting each time? The 12. You're subtracting 12 each time. So take that over. It's minus 381 minus the 3, which is minus 384, is equal to minus 12 into n minus 1 divided by the minus 12. We get it to be 32. And n is equal to 33. And that's done. So, again, this is a sort of thing that I think more recently we've gotten more used to. But if you haven't seen it in some time, at least you've seen it now. I think that's the important, that you have seen it and you know how to use it. Okay. Now, question 3. It says that the first 3 terms of a geometric series 3, 2, 4 over 3, 8 over 9. So we need to figure out what is our ratio essentially. So our ratio, because it's a geometric series, we know it's term 2 all over term 1, which is 2 over 3, which means also that our A value, as you can see, is 3. It says explain why the series converges. Why does the series converge? Because your ratio is between minus 1 and 1. Your ratio is 2 over 3 and it's between minus 1 and 1. Calculate the sum to infinity of the series. Wow, they are making that quite easy. I'm hoping there's a good question after this. I'm seeing there's 5 marks. So I'm hoping there's a decent one for 3.3 and not 3.2 again. So calculate the sum to infinity for this series. Sum to infinity is A over 1 minus R. So our A formula, it's not A formula, A value is 3. Our ratio is 2 over 3. And that's 1 over 3. And then that's just going to give us 9. So sum to infinity is a value of 9. Now for the 3.3, it says express sum to infinity minus Sn in the form of AB to the power of n. Wow. Wow, wow, wow. It's been a long time since I've seen something like this, but it's a good question. It's a really good question. So let me take this and let me use this space now. So we want to express the sum to infinity. We want to express the sum to infinity minus the Sn in terms of just AB to the power of n. So first up, sum to infinity, as we know, is 3 over 1 minus 3 over, well, actually, you don't even have to say that. You know that the sum to infinity is 9 minus Sn, which is A into 1 minus or R, I think it's better to say 1 minus your 2 over 3 to the power of n, all over 1 minus 2 over 3. So what we end up with here is 9 minus, we know that the A value is 3, so that's A value, that's the ratio, So it's 3 into 1 minus 2 to the power of 3 to the power of n, all over 1 over 3, which then becomes 3 divided by the 1 over 3 makes that 9, right? So that's going to end up being 9, yeah. So 9 minus 9 into 1 minus of n. Okay, so we're going to take out 9 as a common factor, right? We're going to take out 9 as a common factor. So if we take out 9 as a common factor, we're left with 1 here. And then it goes into itself. 9 goes into itself there. Well, I shouldn't say itself, but 9 goes into itself 1 time. And then 9 goes into this thing that amount of times. So it's basically minus this 1 minus this 2 over 3 to the power of n. Now, here you can simplify what's in the bracket here. 1 minus 1 plus 2 over 3 to the power of n, which is then going to simplify into 9 into 1 minus 1 cancel, 2 over 3 to the power of n. So this is in the form that they wanted, that this is in the form that they wanted, that ab to the power of n. The a value is 9, the b value is 2 over 3, and there's our n. Good question. Good question, that. I'm happy with that question. It says consider the function f of x, which is minus 2x plus 5 all over x minus 1. Now this is going to be a hyperbola, and it's telling you you need to put it into that form. Again, they started to ask these questions more and more often in these recent years. So again, I just want to make sure we know how to do this conversion. It's going to be a form of your synthetic division. There are other ways to do it, but I like the synthetic division because you're always going to get it right. So the denominator, you just set it to 0. So x equal to 1 is like your factor that you put outside. We know that this is minus 2x. So let me actually write that a little further up here. This is minus 2x plus 5. So the coefficient here is minus 2. The value there is 5. You know that we start with 0 always there. And this, like I said, you set it to 0 and you got a value of 1. So that 1 must go here. And remember, for synthetic division, you're simply adding downwards. So minus 2 plus 0 is going to give me minus 2. Minus 2 times 1 is going to give me minus 2. Adding downwards here, I'm going to end up with a positive 3. And that's the remainder. Now the remainder always goes over the denominator. So it's going to be like this. Your remainder always goes over your denominator. So your denominator is x minus 1. Your remainder always goes on top of it. This value goes on that side. So this is going to be minus 2. So that's what your actual equation of f of x is going to be. It's 3 over x minus 1 minus 2. That's it. It says write down the equations of the asymptotes of f. If f of x is equal... Okay, so now they've given us that equation. I didn't realize they were going to give that to us. I apologize. I should have read further into that. So our asymptotes here, we know is going to be x equal to 1 or y equal to minus 2. 4.3, calculate the intercepts of the graph of f with the axes. So they just want us to figure out what is our x and y intercepts here, guys. I think that's fairly easy for us to do, to be fair. I don't expect us to have any issues with that there. So if we're going to find our x-intercept, we let y equal to 0. So it's 3 over x minus 1 minus the 2. Take the 2 over. Basically, x minus 1 is equal to 3 over 2, and x will end up being equal to 5 over 2. Right, so x-intercept is 5 over 2. Y-intercept, letting x equal to 0, far easier. That's minus 3, minus 2, so minus 5. So those are intercepts. 5 over 2 and minus 5. Okay, let's continue with this here. Sketch the graph of f. So now if we need to sketch the graph, all we need to do is we need to know the following. You know, sketching the graph, you have to have basically 3 things. You need to know the asymptote. You need to know the... Oops. Let me just do that. So you need to know first is normally the shape, right? So you first need to know the shape. Actually, no, it's... The way I taught this initially was I said to sketch a graph, you actually need to just know x and y intercepts. So x and y intercepts. Then the asymptotes or turning points. And then it's the shape. Right? So we know our x and y intercepts immediately. Our x and y intercepts is the 5 over 2 and the minus 5. So 5 over 2 for the x. So 1, 2, let's say it's somewhere here. So 1, 2, 2.5. Right? So let's say it's 5 over 2 is there. 5 over 2. Now, the next thing is the y-intercept. So the y-intercept we're going to say is minus 5, which is going to be there. That's our minus 5. And now it's on to the asymptotes themselves. So we know asymptotes is x equal to 1 and y equal to minus 2. So x equal to 1 is going to be this line here. And then y equal to minus 2 would be this line here. All right, now we just need to know our shape of our graph. So the shape of our graph is important. This graph here, or I should say this graph over here, has your a value there as a positive. So it should be in specific quadrants. Now, if you were going to try and draw it into these quadrants, you'll see that it doesn't go through the intercepts. It needs to be in the first and the third quadrant. There we go. And there we go. Done. That's our graphs. That's our graph of f of x. And f of x, as you know, reads as 3 over x minus 1 minus the 2. Decent graph. It is right down the range of y is equal to minus f of x. So let's say you didn't sketch it, right? Let's say you didn't sketch it. What does this minus f of x actually mean? This minus f of x basically means you are reflecting about the x-axis. All right, so if you're reflecting about the x-axis, what will this new graph's range be? So let's just go and have a look at our graph quickly. If we reflect this graph about the x-axis, it's going to look like this here. It's going to look basically like this here. And then on this side, it's going to go through like that there. So where is it not reaching in terms of the y values? It's still not reaching this y value here. But now I reflected about the y-axis. We're going to reflect about the x-axis. So it's going to look like this here. That's going to go there. So this portion, now this portion is going to look like what on the other side? It's basically going to look like this here. Right, essentially. But coming all the way from the top there. Right, that's what it's going to look like, the reflection. So that's just so you guys can see what it will look like. But you don't actually need to see it, right? What you need to know is the following, right? You just need to know this here. You know what the equation of f of x is going to be, right? You know what the equation of f of x is. You're going to put a negative in front of the f of x equation, which you know is 3 over x minus 1 minus 2. And you distribute that negative inside. So it's going to be minus 3 over x minus 1 plus 2. Which means now we know that our asymptote is y equal to 2. No longer minus 2, it's y equal to 2. Which means the range is y is an element of real, but y is not allowed to be equal to 2. Now, 4.6, it says, describe in words the transformation of f to g. Okay, so what has happened from f to g? So firstly, we can see that they're taking inspiration from this equation already, because we see the minus 3 there is sorted out there already. But what's different are these values here. This is plus 2, here it's a minus 2, which means we would have, first we want to say that we obviously reflected, first you want to say you reflected about x-axis. Then what else did you do? Then we've gone from 2 to minus 2, which means we must have shifted the graph. If you're going to subtract from the end here, if you're going to subtract 4 from the end, that's how you're going to get to this minus 2. So you're going to shift the graph 4 units down. Shift graph 4 units down. And then this last portion here, how did I go from -1 to +1? How did I go from -1 to +1? I must have done this. I must have shifted, or I must have said that it was x plus 2 minus 1, so that I could end up with x plus 1 as I have there. Now it's important to understand that this plus 2 in brackets means that I've shifted to the left. So we know now that besides the shift down, we also shift 2 units left. We've also shifted 2 units left. Very, very good question, that. Okay, so question 5. They give us parabola, then give us the equation of the parabola, and that's okay. Then give us the equation of the exponential either. So let's put them in different colors just so we can see them clearly. So f of x, which is going to be this parabola over here. I have a tendency of putting one in green and the other one in purple often enough. So that's what we're sticking with for now. Okay, it says a is -3 and 0. So a is -3 and 0. Let me write that properly. And b is 1 and 0. Now, immediately with this information that we've been given, we can find the x turning point. Because the x turning point must be exactly in between the x-intercepts. It must be exactly in between those x-intercepts. So our x turning point is going to be what? It's going to be -3 plus 1 divided by 2, which is -1. So -1 is my turning point x value, right? -1 and a certain y value is my turning point there, right? Use a graph to determine the values of x where the first derivative of f times g of x is less than 0. Okay, so this is, they're going straight into this here. I just want to also show you that it says that c is 0 and 6, so I didn't realize they were going to go straight into this. So let me fill in the rest of these values. So this is 0 and 6. You know, it would be easier for me just to show that this is 6 there. And then it says that the graph of g passes through the origin and point 1 and 2. Okay, so g passes through those particular points, through the origin and 1 and 2. Okay, it says determine the values of x where the first derivative of f of x times g of x is less than 0. Now, immediately you need to remember that this means gradient. The first derivative here means gradient. Then here they're saying where is this less than 0? Remember that less than 0 means specifically negative values. How do you get to a negative? A positive times a negative, or a negative times a positive. Now you need to first identify where do you have a negative gradient and where do you have a positive gradient for f of x. So for f of x itself, you have a positive gradient for all values less than -1. All values less than -1, the graph is going up. All values greater than 1, you have a decreasing function. So what we need to look at first is we've said that we want a positive gradient. So we must work with this side of the graph, right? We must work with this side of the graph, wherever the graph has a positive gradient. So on that portion where the graph is positive, where the green graph is positive gradient, where is my purple graph going to be a negative? Now, where's my purple graph below the x-axis? So the purple graph, where is it below the x-axis? Well, it's below the x-axis basically from 0 all the way. However, our portion where they are together, where they are common, is from that -1 all the way to negative infinity. So from -1 all the way to negative infinity, you know that the purple graph is below the x-axis and our parabola is a positive gradient. So this one does exist, and it's specifically when x is less than minus 1. Okay, now let's go and use the logic for the next one. So for the next one, we want to find out where is our f of x graph going to be a negative gradient. So it's a negative gradient when it's greater than minus 1. It's a negative gradient when it's greater than minus 1. So we need to use that portion. So where is my g of x graph? Where's my purple graph a positive? Well, my purple graph is only a positive when it's greater than 0. So where do they both combine? They both combine from here. They are both true from 0 onwards. So yes, they do exist. It's when x is greater than 0. Okay, I kind of enjoyed how they've asked that. That's really nice. Okay, now I'm guessing they're going to ask us to go and calculate all of these values. So it says determine D and Q. Okay, so let's go and put all of this here on the other side. Okay, so for us to go and sort out D and Q, we now just need to go and sub in values. So first up, we know the following. It goes through the origin and those points there. So for us to do this, we're going to say that g of x is equal to d to the power of x plus q. And if we sub in the origins points first for x and for y, that is going to be 0 is equal to d to the power of 0 plus q. This is 1 plus q. So therefore q is minus 1. So we know that the asymptote for this graph is basically minus 1. The asymptote for this graph is basically y equal to minus 1. All right, then we just need to go and sort out the other portion of this equation. So we know that y is equal to d to the power of x minus 1. And we need to sub in the remaining coordinates that we know this graph passes through, which is 1 and 2. So y is 2 and x is 1. Check that over, and d is equal to 3. So that means that the g of x graph is actually, 3 to the power of x minus 1. That's our that's our g of x graph. It's 3 to the power of x minus 1. Okay, now onto the inverse of, g of x. We need to put it into the standard form. So the inverse is going to be really simple. How do we find the inverse? We know that we started off with y is equal to 3 to the power of x minus 1. We swap x and y's. And then we take the 1 over. It's x plus 1 is equal to 3 to the y. The base stays as the base. This is the log of x plus 1. Base 3. That is what the inverse is. It's the log of x plus 1 base 3. State the domain of the inverse. Now the domain of the inverse will equal to the range of my original. So what is the range of my original graph? What is the range of the purple graph? This purple graph is always above minus 1, right? The range of the purple graph for the original g of x graph is y is greater than minus 1. Now you know that when you're going from original to your inverse, your domain and range swap. So whatever was the range for the original now becomes the domain for the inverse, which means here the domain is x is an element of real and x is greater than minus 1. Not y is greater than minus 1. X is greater than minus 1. Okay, determine A, B, and C. I thought as much they'll want us to do that. So here, it's one of those good questions. It's really one of those nice questions where you guys are actually used to this from like your grade 11 work, I should say. So things that you guys know is when you are given x-intercepts and one other coordinate, which formula should you use for your parabola? So you're given x-intercepts and another coordinate. Which formula should you use for your parabola? Y is equal to a into x minus x1 into x minus x2. And now we start with this. So y is equal to an a value that we're looking for, x plus 3, because when you sub it, minus minus makes it positive, and here it's going to be minus 1. And we're going to sub in the other coordinates that this graph goes through, which we know is c's coordinates, which is 0 and 6. So that's for x and y. So y is 6, a is 0, and then here we have it as 6 is equal to minus 3a, because positive 3 times minus 1 gives us the minus 3a there. You divide by minus 3, you're going to get minus 2 for a. Now all you do from here is wherever you see a here, the value of it, you sub it in there and simplify. So therefore y is equal to minus 2 into x plus 3 into x minus 1. Y is equal to minus 2 into x squared plus 2x minus 3 minus 2x squared minus 4x plus 6 is our answer. And that makes perfect sense, because this is the c value and the c value is the y-intercept, and that is what our y-intercept is. Okay, that's just kind of a check to see what it is. Let's go and put down this equation here. So we know that f of x is equal to minus 2x squared minus 4x plus 6. Okay, done there. All right. Draw the graph of the inverse of your parabola. The inverse of f, show the turning point and the intercepts with the axes. Now here, the inverse of this graph, remember, we are reflecting this graph about this line, right? We are reflecting this graph about this y is equal to x line, right? That's what we're reflecting this graph. So that means, first up, we need to know what is the turning point of this original graph. So what I suggest is us just going to find out what is the turning point y value here. So you can just go and substitute minus 1 for x here. So minus 1 in there, that's going to be, that's going to stay as, so it's going to be 8. So this turning point, oh, show it. Sorry about that. That there's going to be 8 as your y turning point value. You can double check that as well, but I promise you it's going to be that. Now, what is your inverse going to look like? We're just reflecting the green graph about this mustard color line. So what's going to happen is this portion, what I suggest you do is you do it like a portion at a time. So you'll see that this here, this turning point must now become the following, right? The turning point will become, let me shift this to that side. So the turning point that was minus 1 and 8 is now going to become 8 and minus 1. So it's going to be somewhere there, and it's going to be 8 and minus 1, because remember, your inverse, your x and y swap. Now that means this is what the graph's going to look like. We are going to have a y-intercept here of a positive 1. I should put it there. A y-intercept there of a positive 1 and a y-intercept here of minus 3. And why should it be like that? Because the original graph has an x-intercept at 1. So the inverse must have a y-intercept of 1. The original graph, the parabola, has an x-intercept of minus 3. So the inverse must have a y-intercept of minus 3. And then the graph just needs to be sketched like that. There we go. That's what the parabola would look like. Done. Oh, and if you want to show another coordinate, you can actually go and show that if the y-intercept is 6, it means that the x-intercept is actually 6 here. Right? The x-intercept is actually 6 here. So it's things you need to know from your inverses. I'm hoping it makes sense, guys. I'm hoping it makes sense there. So that's the sketch. I see the next question deals with the root, so I had to take that away. It says determine the values of k for which f of x plus k is equal to g of x has two roots that are of opposite signs. So what they're saying is that our roots must be of opposite signs, which means how must we shift this graph, right? Because this is talking about a vertical shift here. How can I shift my parabola such that this new graph always has roots of opposite signs? So right now it has opposite signs. It has minus 3 and 1. So the roots or the intercepts are positive and negative. But when will they stop being positive and negative? So if I shift this graph, right? So we know that this coordinate is 6 here. If I shift this graph a total of 6 units down, if I shift it 6 units down, what will happen is my one intercept will be the origin. If I shift it a whole 6 units down, if I shift this a whole 6 units down, my one intercept will be at 0. That's not what we want, because then we have a 0 intercept or 0 root and a negative root. So I can shift my graph pretty much anywhere between 0 units down and 6 units down. Anywhere between 0 units down and 6 units down. All right? Or you can think of it as the following. Actually, I should say it like this. So you find out where it is, where you're going to get your 0 intercept. So like I said, your 0 intercept and then your negative intercept. That's the lowest. Now anything above this, anything above 6 units down, right? Anything above 6 units down will always ensure that we have one positive and one negative. So that means that k, let me just show you. If you put k to be equal to, if you put k to be equal to minus 6, if you put k and you shift it 6 units down, like I showed you, you'd have the 0 intercept and the negative intercept. So we don't need that there. We need to shift it any amount of units greater than 6 units down, right? So we can shift it 6 units down or greater, which means we're basically saying that k needs to always be greater than minus 6, because minus 5 will have positive and a negative. There, positive and negative. If we had it as like 20, we'd also have that there. Positive intercept and a negative intercept. So k must simply be greater than minus 6. So, question 6. It says that Alec invests a lump sum of 5,000 in a savings account for exactly 2 years. The investment earns an interest at 10% per annum compounded quarterly. So this is just a normal lump sum. It says what is the quarterly interest rate for Alec's investment. So they want to know what is the quarterly interest rate. So if it's compounded, if it's 10% that is compounded quarterly, it means that it's 10% divided by 4, which means it's 2.5%. It's a 2.5% like quarterly interest rate. 6.12, calculate the amount in Alec's savings account at the end of the 2 years. Calculate the amount in Alec's savings account at the end of the 2 years. Again, this is ridiculously easy, which I'm certain that everyone would be able to do this. It's just a normal compound interest formula. Just want to use some of the space here. So here we're just going to say it's for 6.1.2, A is equal to 5,000 into 1 plus the 10% all over the 4. and it's for 2 years, so it's 2 times 4, and that's easy, done. So the answer that we're looking for here is 6,091 point, oh sorry, 6,092.01. Now, on to the next one. 6.2, it says a school issued new laptops to each of its 110 employees at the beginning of the year. It says the school was advised to set up a sinking fund to ensure that there would be enough money to replace them at the end of the 5th year. All right, so it says that the following applies. They paid 6,000 for each laptop. Fine. So we got to just say 6,000 times 110. That's the first thing, which is basically like 11 times 6, which is 66. But then this ends up being 666,000. It's just by carrying those extra 4 zeros that's there. Yeah, you can check that on the calculator, but I promise you that's what it is. Laptops depreciate at 15% per annum on the reducing balance method. For perfect. So that's this formula here for depreciation. And then it says inflation. Okay, so inflation is at 6% over the 5-year period. So A is equal to P into 1 plus I to the power of N. And let me actually just go and fill in those values there. So depreciation is 15% to the power of N. And inflation is at a standard 6%. A sinking fund is set up such that all payments will receive 12% interest per annum compounded monthly. So this sinking fund is basically going to be monthly installment type of sinking fund. It says determine the amount of money required at the end of 5 years to replace the laptops. Now, you need to find out how much of money is actually required to replace these laptops. And this is a fantastic question. So we first got to figure out how much are these laptops going to be worth after the 5-year period. Then we've got to figure out what will the new laptops cost, and then figure out what our amount is for us to be paying monthly, or what our monthly amount needs to be. So first, let's go and figure out how much the trading or carrying value of these laptops are after 5 years. So 6.2.1. So first up, we know that it's going to be 660,000 is what the laptops are worth. So 1 minus the 15%, all to the power of 5. So that there is going to be worth, and I should have been fast on the calculator with that, 66,000 to 1 minus 15% to the power of 5, and that's 292,845.51. Now this is basically like your carrying value or your trading value, all right? What we're going to do now is we're going to find out, okay, what will be the new laptop's price? What will be the new laptop's price? So the new laptop's price is going to be A is equal to 660,000 into 1 plus the 15, oh, not the 15, it's the 6, it's the 6%, right? It's the 6% here. And that's for 5 years. So here we're going to have this as 660,000 into 1 plus 6% to the power of 5. And this is going to be 883,228.88. Okay, so we now need to sort out what our monthly deposits are going to be, because they say here we need to determine the amount of money required at the end of the 5. Oh, sorry. We just need the amount of money that is required. I thought we needed to find the monthly monthly payments. I see that's the next one. So how much of money do we actually require? We're just going to subtract the two. So amount required, or amount that we are saving towards, is going to be the difference between these these two, 883.228 minus, 0.88 minus 292.845.51. And that's 590,383.37. All right, so that's how much we're working towards, right? 590,383.37. It then says we need to determine the monthly payments that should be made into the sinking fund to ensure that all 110 laptops can be replaced at the end of the 5 years. Fine. So all we're going to do is we're going to be putting this into a future value formula. We know what we're working towards, and we know it's for over a 5-year period. So we are working towards 590,383.37 with monthly deposits of what we are unsure of into 1 plus an interest rate. Interest rate that they told us is 12% per annum compounded monthly. So 12% per annum compounded monthly to the power of 5 times 12 minus the 1 all over 12% over 12. Division is going to become multiplication. Multiplication is going to become division. Let's put that in the calculator and get a value here. So I'm getting 7,228.92. So it's going to cost the school 7,228 rand and 92 cents every month. They got to put that money away so that in 5 years they can replace all laptops. Okay, so question 7, it says we need to differentiate f from first principles if f of x is equal to 3 minus 2x squared. So we know how to do first principles by now. I'm pretty certain that we know how to do first principles. So 7.1, they tell us that f of x is equal to 3 minus 2x squared. Now we've got to figure out what is f of x plus h first. So 3 minus 2x plus h squared. 3 minus 2 into x squared plus 2xh plus the h squared. 3 minus the 2x squared minus the 4xh minus the 2h squared. Now what we go and do is we're going to use our formula. We say that the first derivative is equal to the limit as h approaches 0 for f of x plus h, which is 3 minus 2x squared minus 4xh minus 2h squared minus this 3 minus the 2x squared. But now what I'm going to do is I'm just going to show you immediately we're going to distribute that negative inside. So if you're going to distribute that negative inside, it's going to end up with minus 3 and then plus 2 there. All over h. We're going to see that our terms from the f of x are going to cancel out. The 3 and the minus 3, the minus 2x squared and the positive 2x squared cancel out. And what we're going to be left with is the limit, as h approaches 0 for minus 4xh minus 2h squared. So we're going to take out h as a common factor here. So this is minus 4x minus 2h all over h. The h's are going to cancel out. And wherever you see h after that, you put it as 0. So minus 4x is our answer. And we know the derivative of this is just minus 4x. We know that, right, from the shorthand version. Okay, now on to 7.2.1. It says evaluate dy dx if y is equal to this here. Okay, so we're going to use this space here to just do this. We know that we've got to deal with x as a numerator and no roots. It must always be an exponent form. So this is minus 1 times x to the minus 1, converting that. And then the root is going to be x to the power of a half. So plus x to the power of a half. Now, if we're going to find the derivative of y with respect to x, this is going to be minus 1 times the minus 1, which is going to give us a positive 1, because exponent times coefficient. and then subtract 1 from the exponent. This is going to be a half x to the minus a half. And that's it. Done. Next, 7.2.2. We'll use the space on this side to sort this out. So 7.2.2. I see what they up to here. Okay, so let me explain what's going on here. So dx 8 minus 3x to the 6 all over 8x to the 5. Now, you have a single denominator, which means you can put it over this term and then over that term individually. So that's where we're going to start this. So here, you're going to start this off by saying that this is basically 8 over 8x to the 5 minus 3x to the 6 all over 8x to the 5. Now we simplify this. 8 cancels out with the 8. We take the x to the top. So this is going to be x to the minus 5. Here, that cancels with that. Then you're left with 1x at the top. So this is minus 3 over 8x basically. Now we just find the derivative. So derivative of x to the minus 5 is minus 5x to the minus 6. And then minus 3 over 8. And we're done. Okay. Now on to question 8. Question 8, it says, sketch below is a graph of a cubic function, ax cubed plus bx squared plus cx plus d. A is minus 6. Okay, so a is minus 6, b is minus 1, c is 2, and f is 0 and 24. So they've given us our factors here already. So what you can actually do is the following. You can structure this. When you're given each of your factors, you can do the following. You can say that f of x is actually equal to a into x minus x1, x minus x2, x minus x3. You know, like for the parabola where you had the x-intercepts, it's a similar concept. So here you have your function. So far, you have it as x plus 6 because the first intercept was minus 6. And then here it's going to be plus 1 because the other intercept was minus 1. And this is going to be minus 2. And then we have f coordinates. So the coordinates of f here is 0 and 24. Right? 0 and 24. Which means we're going to just sub that in. We're going to sub that in as 0 and 24. And we're going to figure out what is our a value. So 24 is equal to a into 0 plus 6 plus, well, plus 1. I should say 0 plus 1. 0 plus 1. 0 minus 2. So 24 is equal to minus 12a divided by minus 12, and that's minus 2a. Now, minus 2 is going to be distributed there. So what we're going to have as our function, and I'm pretty sure it's going to be one of the questions, what they're going to ask us is to find the equation of this function. So I just want to show you what it would look like. We're going to put minus 2 here, and it's going to be x minus 6, x plus 6, x plus 1, and then x minus 2. Okay, so let's go and do this quickly. So we've got to go and distribute this out. So I wonder if they actually give us the form. Yeah, there we go. So they already told us that a is going to be minus 2, b is going to be minus 10, and c is going to be 16. So we know basically that we're just distributing this out and then distributing the 2 thereafter. And it's quite clear that we are on the right track because our a value we got is the minus 2 that they told us. So now we can just go and show that our f of x graph, f of x here, is equal to minus 2x cubed plus, wait, I should say minus 10. Minus 10x plus, I need to write that better. Minus 2x cubed minus 10x squared plus 16x plus 24. It says determine the coordinates of D. D is the turning point there. We've got to figure out what is our turning point. We know how to do that. Turning point we know. It's just first derivative equal to 0, and then we sort it out. So let me just go and write this for 8.2. First, let me just write out that f of x equal to the minus 2x cubed minus 10x squared plus the 16x and then plus the 24. So first derivative is going to be minus 6x squared minus 20x plus the 16 equated to 0. We're going to get our x values, and x values, we'll probably get decent x values here. Let me just see on the calculator. So we're going to get this to be minus 4 and 2 over 3. And obviously minus 4 is the one that we're looking for because D's coordinates is going to be obviously a negative 4 for the x value. So that's negative 4 and a certain y value. So you can substitute the x value into your equation. What I would actually do is I would take it and sub it into this one because it's a lot easier to work with. So my corresponding y value then would be, it's minus 72. Okay. So minus 72 there. So this is minus 4 and minus 72. And then we can do the same thing and sub in this here into there and get our corresponding y value for the other stationary point. Now let me go and do that as well. Okay, so it's 800 over 27. All right, so that is E's coordinates. E's coordinates is, I was going to say, it's 2 over 3, and then 800 over 27. Okay, I think I need to move this now. It's really getting in the way now. It says for 8.3, write on the value of P and Q if the graph is translated in such a way that the point D is moved to the origin. Okay, so point D is moved to the origin. What is the new graph has the equation of minus P plus Q? Okay, so what they're saying here is this minus P is representing a horizontal shift, and then this plus Q is representing your vertical shift. So how must you move this particular graph so that it's point D is at the origin? How do we move it? So we must move it 4 units to the right. So that means it's going to be f of x minus 4, because minus 4 is a shift to the right. And then how many units up must we go? We must go 72 units up. We must go 72 units up so that we can end up there, essentially. So 72 units up, so plus the 72. And that's that. Okay, now 8.4. Oh, this is really good. So 8.4, it says, for which values of x will the second derivative times the original be greater than 0? Okay, now this is a very, very important question, right? So your second derivative, all right, is basically like this. Let me explain this in the following way. So your original graph, right? Let's say we dealt with the original graph being a cubic. Then we know that our first derivative is basically going to be a parabola. And if we had a negative cubic, we'd have a negative parabola. But now let's think about this graph here. Let's think about the parabola graph. Now, if I derive the parabola graph, if I derive that one more time, if I derive the parabola graph, I'm going to get some sort of straight line. And remember that the straight line is going to be a negative straight line. So what we're saying is
is that the derivative of the parabola must give us the gradient of the parabola, isn't it? The derivative of the parabola must give us the gradient of that parabola. Now, we need to see where would this gradient be a negative or a positive and so on with, and this is what we need to understand. So we're going to go and put down our point of inflection. This is the most important thing here. So our point of inflection is going to be the midpoint between our stationary points. So we're basically going to say minus 4 plus the 2 over the 3, and then we'll divide that by 2, and we're going to get that as minus 5 over 3. So minus 5 over 3 is our point of inflection x value. We're not really concerned with the y value for now, but the x value is important. Okay, so this is telling us the following. Okay, you know that a negative parabola looks like this here. So you will have a positive gradient until the point of inflection, until that point of minus 5 over 3, and this, whatever, we don't care about what its y value is for that. We just know it's minus 5 over 3. And then anything greater than minus 5 over 3 will have a negative gradient. So this is what we have to understand. We have to understand that anything on this side, anything on that side of minus 5 over 3 will result in your second derivative being negative. Anything on this side of minus 5 over 3 will result in your second derivative being a positive. Okay? Very good question. Actually, I haven't seen this type of question in some time. Quite excited for it. So, how do we now then do this? We know second derivative times the actual graph needs to be greater than 0, needs to be positive. So there's only two ways you can get to this being positive, is when it's positive times a positive, or when it's negative times a negative. So where is my original graph? Where is my original graph? Positive. Sorry, not my original graph. Where's my second derivative? Positive. Where's my second derivative? Positive. It's positive only on this side here. Right? It's positive only. Let me put it in the green. It's positive only when it's less than minus 5 over 3. So we must have a look at that region, right? We have to have a look at that region. So in that region, where is my graph? Where's my black graph? Where is that positive? So my black graph in that region is positive when it's less than minus 6. So yes, this does exist. It's when x is less than minus 6. That's one answer. Fine. Now we've got to do it for the next piece. Where is my second derivative? Negative. My second derivative is negative for all values greater than minus 5 over 3. For all values greater than minus 5 over 3. Fine. So in that region, right? So in this region here, going to infinity, positive infinity. Where is my where's my black graph? Negative. Where is that black graph negative? So it's negative from minus 5 over 3 to minus 1. And then when it's greater than 2, it's negative again. So yes, this does exist. It's for when x is between minus 5 over 3 and minus 1. So between minus 5 over 3 and minus 1. Or when x is greater than 2. Or when x is greater than 2. Okay, sort it out. Again, phenomenal question that. Okay, now the next one for 8.5. It says, for which values of k will f of x plus k equal to 0 have 2 negative and 1 positive root? So what we have to do here is understanding how we're shifting the graph vertically. So for us to continuously have two negatives and one positive root, what we need to ensure is that our graph must always be on, it can't go above this negative 72, right? It can't go, if it goes above this negative 72, or if it just touches it, we would end up with a positive, and then we'll end up with a negative, right? So if it just touches it, it's going to be one negative, one positive. That's not what we want. We want to keep it as two negatives, right? Two negatives and one positive. Now, the only way to do that is to ensure that it is between zero. We shift it between 0 and 72 units up. Not all the way to 72, because if we do shift it up exactly 72, we know that it's going to look like this here. It's going to go up and then come back down like that there. And it's going to have one negative and one positive root or intercept. We want to make sure that we continuously have two negatives. So we're going to shift it. We can shift the graph up between 0 and just less than 72, because then all the time we're going to have two negatives and one positive root. So we're going to say that k must be between 0 and 72 to ensure that we always have two negatives and one positive root. Okay, so question 9, it says refer to the figure showing the parabola given by this equation. Okay, so now immediately, as soon as they tell you, and this is going to be your maximization or optimization questions, it's telling us that y is equal to 4 minus x squared all over 4. That means wherever we have points on this, right, wherever we have points on that there, we can think of any point on here being the following coordinates: a certain x value, and the y value we know is going to be 4 minus x squared over 4. That's what it basically means. So we can immediately say that B's coordinates, okay, I'm sure they're going to tell us, okay, with 0 less, okay, it's basically from 0 to 4 is the point x and 0. Okay, so D is that point there. DB is parallel to the y-axis, fine. And it says, with, okay, so, yep, we know that this is D's coordinates, and B's coordinates, they've actually, it's really small to see, so I'm just going to put it a bit bigger there so we can see it. X coordinate here is going to be 4, well, sorry, X coordinate is going to be X, and the Y coordinate is going to be 4 minus X squared all over 4. All right. And they obviously have the same x value. The D value, or D coordinate, and B coordinate basically have the same x value. It says write down the coordinates of B in terms of x. We've done that already. Next up, it says show that the area of triangle OBD is given by this here. So triangle OBD, which is our blue triangle that they've done here. OBD, right? We need to show that the area is given by that. So what is area essentially? Area is a half of the base times the perpendicular height. Because you know this is like 90 degrees, right? You know this is 90 degrees. So you have a base of x and a height of 4 minus x squared over 4. So it's going to be your area is a half of your base times your height of 4 minus x squared over 4. So we'll just keep this as x, a half x into 4 minus x squared all over 4. This is going to give us 2x minus x cubed all over 8. Okay, that's what it should give us. Now, unfortunately, I think they made a mistake here. It shouldn't be x squared over 8. It should have been x cubed over 8. So that's probably a mistake on their side. 9.3, determine how far D should be from O in order so that the area... Okay, so it's basically just to optimize that point so the area is as large as can be. So we're going to find out what is the x value essentially, right? So what is the x value? So we just got to maximize this here. So we know our area formula is 2x minus x cubed all over 8. First derivative is going to be 2 minus the 3 over 8x squared. We solve for this here. It's going to basically be, let me do it like this here, step by step. Over 8x squared is equal to 2. That's 16. So it's x squared 16 over 3, which is then just going to be, once you square root it, once you square root this, you end up with, well, actually, I should do this because then it's not going to give you, your calculator will actually give it to you in the right form, which is going to be 4 root 3 over 3. 4 root 3 over 3. Right, so that is the value of x to maximize our area. They're not asking for the maximum area. They're simply asking us what must the coordinate, or how far should D be from O, so that the area is as large as possible. So basically the x value should be 4 root 3 over 3. Or you can even round that off because it's just the value you need to show. Okay, now question 10. Contingency table. It says in a survey, oh, they've asked this question before. I think this is an old paper. This is an old, I think 2010, maybe 2011 paper, I think. It says broken limb, not broken limb, male, female skydivers. Basically just figuring out how many of them have broken a limb, how many of them haven't, and male, female. So 2.1.1. Calculate the values of A, B, C, and D. So easy stuff here. This plus something must give me 913. So we just need to subtract. And that's going to be 450. Then it's going to be 463 plus B must give us 782. So B will have to be 319. And then 319 plus C to give us 617. And that's going to give us 298. 298. And then here you can add this up here to get you your D value, or you can even say this plus your D to give us 1530. So I'm going to go this way because it's just easier numbers that way there for me, and that's 748. Okay, so it says calculate the probability of choosing at random in the survey a female skydiver who has not broken a limb. So female skydiver who has not broken a limb. So female skydiver who has not broken a limb. So it's 298 out of the 1530. So 298 out of the 1530. Easy. It says determine whether the events of being female and having a broken limb are independent. What do we know about independent events? We know that probability of A and B is supposed to equal to the probability of A times the probability of B. So now let's go and show this. They're saying that we need to determine whether the probability of being female and having a broken limb are independent, right? If they are independent. So that means we need to structure it like this. We got to say probability of female and broken limb, they said. And broken limb should be equal to the probability of female, times the probability of broken limb. So what is probability of female and broken limb? Female and broken limb is 450 out of the 1530. So 450 out of the 1530. Probability of female, what's the total for female? 748 out of 1530. Probability of broken limb is 913 out of 1530. Right, so we just got to put this into our calculators to get our values on each side. So here I get 0.29 essentially. The other side I have 748 times 913, 0.29. And if they are equal, therefore they are independent. Right? Therefore they are independent. Right? Therefore they are independent. Good question. All right, 10.2. It says that given the word hammerhead, okay, so first up, how many letters do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 letters. And then we also have repeating letters. So I just want to make sure I underline the repeats. So we know M and M, A and A, and then E and E. There's repeats. It says how many unique 10-letter words can be formed using the letters. Okay, so here's how many, like the number of, it's like the number of arrangements is what it is, right? So number of arrangements is basically the total number of items that you have divided by the number of repeats. So how many H's do you have? You have 2. How many A's do you have? You have 2. How many M's do you have? You have 2. How many E's do you have? You have 2. Okay, so that just sorts out each of those there, done, and whatever that value is. It shouldn't be too big of a number. Just 10 factorial all over. So 226800. 10.2.2. It says find the probability of 10 letter words formed such that the letters R and D are next to each other. So R and D to be next to each other means you can think of it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The letters R and D, they are now gonna represent like one unit. 1, 2, 3, 4, 5, 6, 7, 8. So you have 9 other units to essentially like rearrange. So that's immediately 9 factorial, right? 9 units to arrange, 9 factorial. Now in those 9, we see that R from the top there, from the top we see that R and D don't have any repeating letters, right? R and D, there's no other additional repeating letters. But then the rest of those repeating letters have to be taken into account. So you've got to go and figure out how many times is H repeated? Still twice. A is still repeated twice. M is still repeated twice. And E is still repeated twice. So now we just need to put this in our calculator. And that's 22680. Which means they wanted the probability. Our probability is our outcome over the total number of outcomes, which is a perfect 0.1. Oh, and I actually forgot about this, and this is actually really bad of me. I'm so sorry about this. I've made a mistake here. I'm just looking at it now. I forgot. I said that that's 1 unit, but obviously that could be R and D or D and R because they just need to be next to each other. And I apologize for this. This should have been times 2 factorial there at the top here, because inside here, they can be in 2 factorial ways. So this will just be doubled. Whatever this answer is going to be doubled basically. So 22680 times 2. Which is 45360. 45360. So this is actually going to be 0.2 then as a probability.